Hello everyone, this is Siddiqur Rahman and welcome to the third lecture of the fourth week. So let's start. By the end of this lecture, you guys will able to describe what is subtractor, what is half subtractor, as well as what is full subtractor. So let's start with the outline of this lecture. By the I repeat again, from this lecture you guys will learn several things. We have already know what we are learned from the previous slide. Just to as a description, or if we split the main word, then we get overview of subtractor, classification of subtractor, overview of borrow, overview of subtractor as well as full subtractor along with its block diagram, half subtractor logic circuit as well as full subtractor logic diagram as well as logic circuit, and so on. So let's start with the overview of subtractor. Subtractor is a mathematical operation in which one integer number is deduced. Sorry, I repeat again. Deduced, you can say deduced or you can say deducted from another to obtain the equivalent quantity. The number from which other number is to be deducted is called minuend, and the number subtracted from the minuend is called subtrahend. The binary subtractor is another type of combinational arithmetic circuit that produces an output which is the subtraction of two binary numbers. As their name implies, a binary subtractor is a decision-making circuit that subtracts two binary numbers from each other, for example x minus y, to find the resulting difference between the two numbers. Unlike the binary adder, which produces a sum as well as a carry bit when two binary numbers are added together, the binary subtractor produces a difference, which is in short D, by using a borrow bit, which is in short capital B, from the previous column. Then obviously the operation of subtraction is the opposite to that of addition. Now time to learn classification of subtractor. Subtractor are classified into two types, such as one is half subtractor and another one is full subtractor. Now start with the concept of half subtractor. The half subtractor circuit has two inputs, such as capital A as well as capital B, which add two input digits and generate a borrow as well as a difference. And figure 1 represent the concept of half subtractor, as we have already just learned from the concept that half subtractor has two inputs, one is A and another is B, and when these two digits are add or subtract, then we get two parameters, one is difference as well as borrow. Difference is we can use the short form of difference is capital D, and for the borrow we can use B naught. Now start with the concept of full subtractor. The full subtractor circuit has three inputs, which is A, B and B in, which add the three input numbers and generate a borrow and a difference as well, like half subtractor. But the difference is half subtractor has two inputs. On the other hand, the full subtractor has three inputs. Well, figure 2 represent the concept of full subtractor, and you can see from figure 2, in the left side the inputs are symbolized. One is A, another one is B, and another one is B in. And in the right side of the figure you can find the output section of full subtractor, which is one is difference, another one is borrow, or you can say borrow out. Now a question may arise in your mind, what is borrow? Sometimes you can, sorry, I repeat again, sometimes when you are subtracting large numbers, the top digit in a column is smaller than the bottom digit in that column. In that case, you need to borrow from the next column to the left. And figure 3 represent the concept of borrow. Just focus on the figure. You may find there are two columns. One is right column, and you need to imagine that column. In the right column you may find two numbers. One is 2, or you can say the top digit is 2 and the bottom digit is 3. In the left column you may find just one digit, which is just 1. And if we subtract the upper portion, if we subtract the bottom portion from the upper portion, then we may face difficulty, because in the right column the top digit is 2 and the bottom digit is 3, and 2 is smaller than 3. So in the right column 2 is since 2 is smaller than 3, that's why we need to take 1 as a borrow from the left column and placed it beside 2. In that case the new number would be 12, and you can see in cloud section the 2 is written with borrow, which is 12. Now you can subtract. If we subtract 3 from 12, you can get just only 9. And since you borrow 1, which is already which is in the next step, which is shift in the left column, which is 1 minus 1 equals to 0. You can write the subtraction value is 0.9, or you can just only write 9. So I hope you are understand the concept of borrow. Next, in this slide you may find there are also one or two example. You can say one example in an elaborate way, the concept of borrow. I hope if you look at this example, then you may don't find difficulty. So let's move into the next slide. Now time to learn HalfSubtractor. HalfSubtractor is a combinational circuit which performs subtraction of single bit binary numbers. The subtraction combinations of the two single bit binary numbers can be 00, 01, 10, 11. And in the second case, when 1 is subtracted from 0, then we need to borrow 1. Rest of the three cases we do not need any borrow. And figure 5 represents the block diagram of HalfSubtractor, and in the left section of the block diagram you can find two inputs. One is X and another one is Y. And in the right section you may find two output. One is difference and another one is borrow out. Difference is symbolized by capital D, and borrow out is symbolized by B out. Now time to learn the circuit about HalfSubtractor. A HalfSubtractor is a logical circuit that performs a HalfSubtractor is a logical circuit that performs a subtraction operation on two binary digits. The HalfSubtractor produces a sum and a borrow bit for the next stage. And figure 6 represents the circuit of HalfSubtractor. And in this figure you may find three gates are used to implement HalfSubtractor circuit. One is XOR, another one is AND, and another one is NOT. if you remember the circuit of half adder, then you may find the difference between half adder circuit and the half adder subtractor. In the half adder circuit, there is no NOT gate in the input section, but in HalfSubtractor there is one NOT gate. I hope you understand between the difference between two things. One is half adder and another one is HalfSubtractor. So let's move into the next slide. Now time to learn about the truth table of HalfSubtractor. Figure 7 represents the truth table of HalfSubtractor circuit. Well, as we already know that HalfSubtractor has two input, which is symbolized A and B, or you can say X and Y. For this, we need to assign two individual or two single binary number. One is 0 and another one is 1. In that case, we get the combination of these two numbers is 4 combination. Okay, one is 0 0 0 1 1 0 and 1 1. In the output section, which is one is difference and as well as another one is borrow. In difference section, we get only 1 in two condition, when one of the input is 0 and the another one is 1, and vice versa. Vice versa means one of the input is 1 and the other one is 0. In this case, we get only 1. Rest of the cases are 0. And in the borrow section, we just get 1 in one condition, when X is 0 and Y is 1, or you can say A is 0 and B is 1. I hope you understand why we get 1 in borrow, because 0 is smaller than 1. From the truth table of the HalfSubtractor, we can see that the difference output is the result of the exclusive OR gate, and the borrow out is the result of the NOT hyphen AND combination, as we have already seen from the previous slide. Now from this slide we may learn the Boolean expression for a HalfSubtractor. For the difference bit, we get X XOR Y, and or you can say A XOR B. And for the borrow bit, we get NOT X and Y. Now from this slide we may learn FullSubtractor. Well, a combinational logic circuit performs a subtraction between the two binary bits by considering borrow of the lower significant stage is called as the FullSubtractor. In this, subtraction of the two digits is performed by taking into consideration whether A1 has already borrowed by the previous adjacent lower minuend bit or not. Well, figure 8 represents the block diagram of FullSubtractor, and we have already known that FullSubtractor has 3 inputs, such as A, B or B in. Sorry, I repeat again, A, B and B in, or you can symbolize by in this way X, Y and B in. And in the right side you may find 2 output section. One is difference, which is in short, or which is or you can say which is symbolized by D, and borrow out, which is symbolized by B out. From this slide you may learn the logic diagram of FullSubtractor. Well, you may see or you may find there are 2 HalfSubtractor of this diagram. One is left section and another is middle section, and another thing you may find there is a OR gate which has there is sorry, I repeat again. Another thing you may find from this logic diagram of full subtractor, which is one OR gate, and which has two inputs, and two inputs are connected to two subtractor. As the full subtractor circuit above represents two half subtractors cascaded together, the truth table for the full subtractor will have 8 different input combination, as there are 3 input variables. The data bits and the borrow in B in input also includes the difference output D and the borrow out bit. From this slide, you guys will learn about the circuit of full subtractor. So full subtractor is a logical circuit that performs an subtraction operation on the 3 binary digits, and just like the half subtractor, it also generates a borrow out to the next addition column. Then a borrow in is a possible borrow from a less significant digit, while a borrow out represents a borrow to a more significant digit. Now time to learn about the truth table of full subtractor. As we have already know that full subtractor has 3 inputs, so we find or we need 8 combination of 3 binary numbers. And if you see in the output section, or more specifically in difference section, we may find 1 in for the 4th condition, and in the borrow section we may also find 1 for the 4th condition. Now from this slide we may learn the Boolean expression of full subtractor. For the difference bit we may find inside of the first, sorry, I repeat again, inside of the parenthesis X or Y or borrow in. For the borrow out bit we may find not X and Y, or inside of the parenthesis, or you can say not inside of the parenthesis X XOR Y and B in. Now time to learn some applications of half subtractor, such as to subtract the numbers present in the least position at the columns. These subtractors are preferred. Next one, the arithmetic logic unit present in the processor prefers this unit for subtraction. Next one, to minimize the distortions in the in the sound, these are used. 4th one, based on the operation required, the half subtractor has the capability of increasing or decreasing the number of operators. 5th one, half subtractors are used in amplifier. 6th one, while transmitting the audio signals, these are used to avoid the distortions. From this slide we may learn some of the applications of full subtractor, such as to perform the arithmetic operation of subtraction, that is in the ALU, which is elaborately said arithmetic logic unit. These subtractors are preferred. These subtractors means full subtractor. Next one, the microcontrollers understand well the language of binary, hence the operations performed by microcontrollers require the circuit of full subtractor to perform binary subtraction. Next one, in gadgets like calculators and other electronics devices where it involves binary numbers, these circuits are preferred. Next one, the systems based on networking prefer this kind of circuitry. In the next week in the next week you may learn encoder, decoder, parity checker and parity generator. So that's all for this lecture. Thank you guys for your attention. See you guys in the next week and next lecture. Thank you.